Okay, not quite sure why this isn't working over here, but let's just get set up here with our chat. I'll just point out also I have a really nice big 24-inch monitor here. Why can't I expand this down? What happened there? My screen's bigger, right? So I need to either expand this out. There we go. Let's see. Let's do this. Let's okay. Oh shit. Let's just put like I said, I got a brand spanking new monitor, 25-inch. Unfortunately, I can't get the built-in webcam because I don't have the right because I had to use a special cable, and the cable doesn't work with my computer. So anyway, hey, welcome back to the Caribou Data Science Channel. This is the evening of, well, this is the evening of, uh, okie dokie. Unfortunately, the new monitor doesn't make me look any better. Uh, Also a little off center, but that's okay. So anyway, welcome back to the Caribou Data Science channel. This is the evening of, well, this is the evening of, this is the evening of, This is the evening of, well, it's the evening of Tuesday, January 24th, 2023. Good news is I got a new monitor. Bad news is, well, it's the latest, greatest monitor. I, uh, I can't really use the built-in webcam because it needs a different type of cable. And the cable that it works with doesn't apparently work with my computer. Okay, I tried it twice and it doesn't want to work right. But nonetheless, let's just back you folks in 15 minutes to get this show on the road. Okay. Wait a second. What's what scroll would it cover? That's interesting. That means God gave you some instruction. Why are you going to find? But Yahweh did give them some, but Adonai did give them some commands previously. Are you watching all three? Are you watching all three of them? You're watching all three of them. Okay, well, finish with them. Finish with them. You made three movies with the same character. Okay. Bad market. So what was last one? Hang 'em high, something like that? You watch Hang 'em high? What was the first one you watched? That's the one I watched. Oh, yeah. So it's Hang 'em high, okay, and a few dollars more. I don't know, Hang 'em high. And the third one is for a few dollars more. Yeah. Okay. Welcome back to the Caribou Data Science channel. Again, this is the evening of, what is, this is the evening of, uh, well, Tuesday, January 24th, 2022. What happens if I close that window? So yeah, I hope you can tell the difference. This is a nice big 24-inch monitor. I mean, the thing that's great about this, I can actually have two windows open side by side and still have them readable. Let's just take a look at one thing over here. I'm still having trouble getting even a prime. Okay, so good. So it did start to correct thing. So where are we at here this evening? Well, we'll come back over here and we're going to try to finish our mod. There's a data wrangle function. And our goal is to try to finish project 23, I think. Is that where we're at here? Is it 23? 24. 24. Okay. We'll do an edit on this. And I got this code here from the forum. Okay. But anyway, tonight's session, our goal is to finish 24, what do you call it, 24th project. Yeah, let's call these projects, and then we call the assignment the final thing. So the 24th, the 24th project, which is price and everything. Then maybe tomorrow night we'll start the assignment. Okay, but anyway, so we have to start over here first of all. Yeah, just look at the size of this screen here, my friends. Look at this thing. No resharing of the notebooks with friends and colleagues. No downloading. No resharing. Let's come back down here. Everything should run down to here. Now this was also added, so we should get an error on this because this was also added to the function, or maybe not. Nothing like a nice big screen here. So now we're going to. So this is just our function here. Okay, that's all this is. Does this give us an error? Yeah, because the columns aren't there anymore. Okay, let's just check this here. So is this also surface area and room? So is this also removed from the function? Good. Let's come back up here, just for the fun of it. Let's see if this just gives us the matrix. Yes, it does. Okay, good. So this ran the heat map. Well, we have to do something like price, surface total, and well, the obvious question is why is this here? All this stuff here should have been removed. What has happened is over the last couple of days, maybe week or so, the display on my laptop started to go out. So I decided to go out and buy a new monitor, and this is the result of that search on YouTube or on on Amazon. I happen to have $50 in gift certificates, which lowered the rate a little bit. Uh, what this does, this bypasses even if the display on the laptop goes out, I still this one here still works. That's the main reason we use it. So do I have this up here? Okay. I'll just come back down here then. And we'll just do this here. All right, so this is where we are. Let's just back up here. Now it's just 2.8. Now this should not, so this should, I, I still think that, the price per square meter is a good measure. That means I'm missing something here. Now this must be, hmm, hmm. Right, okay. Good, good, good. Next train is Y train. And that, my friends, is fantastic. It is absolutely fantastic. Okay? This means we are good up to 2410. Okay. So let's see if this rascal looks any better on the bigger screen. My guess is probably not.
All right, we're on to model building. So let's reapply or reinforce all of the skills that we've been learning this lesson. I'm going to go here to the notebook, and the first thing we need to do is we need to create a baseline. So I'll zoom in, and the first thing I need to do, this should almost be muscle memory for you at this point, is I need to set my mean. So I'll do ytrain.mean. There we go.
What about
And actually, let's take this here. Let's just print this out so that we have it. So I'll do mean apartment price will be, let's round this to 2 decimal places. And then here we'll do y mean. Beautiful. So here's our mean apartment price, 100. $132,000. Excellent. The next thing we need to do is we need to create our baseline prediction. So y predict baseline, and that'll be equal to y mean in a list multiplied by the length of y train. Awesome. And last but not least, we need to calculate our mean absolute error. So I'm actually going to do that in the print statement just to be a little bit more Pythonic. So I'll do mean absolute error, and I'll do y train versus y predict baseline. Beautiful. And I'll hit Shift and Enter, and bada bing, bada boom. Boom. We have our mean apartment price, $132,000. And if we always guessed that on average, we would be off by around $44,000, $45,000. Excellent. All right, let's start with the model building.
Hmm. Hmm. Let's come all the way down here. Let's look for model. Hmm. Let's make this. Hmm. Hmm, that works. That's the trouble. Now we got our feature matrix, okay? Well, there it is. Excellent. Okay, very good. Excellent. So it actually is there, right? So this runs fine. This works. This works. And this works. Hmm. Hmm. Well, you know what the axis, it's acting like, okay, that the imputer isn't working. Hmm. Let's come back up here. Okay, but I don't see any NAs in this. Okay, so hopefully someone will help. Otherwise, I won't be able to complete this lesson yet. But anyway, let's call it a quit on that one there then. And let's take a 15-minute break. Then we'll come back and we return to data analytics at the command line, run and puppy Linux. Okay. You know, I certainly hope. Hmm, you know, I may have screwed up here. I may not have got. The giant starting to start streaming. Okay. Well, I apologize if I totally screwed up the first part of this stream by not getting rid of this screen here.
Okay. A lot of files, and they've broken it down into batches. But before we get too far
Although the
into
good news
this,
is,
hey there, what else? Who's that? We got
you
chatting.
didn't.
Who's that we got chatting? Lots of biology stuff going over my head. This isn't biology. This is like
like I said, this
really
you
quite
didn't miss much.
understand.
You must be not thinking I accomplished something, but not, and in the end, not
Neutrinos.
doing it. Okay,
That sounds a
I'm
lot
having a
better.
trouble
Giovanni, thank you.
trying to fit a
Neutrinos.
model.
We're
It says
measuring
about some,
the direction of
some
neutrinos in the edge.
missing values in it.
I'm
I
looking for
don't think I
Peru.
do.
This is my
Of
first
course, you
live
did
video.
run
Yes,
a.
Daniel, welcome to the chat. So happy to have you. All right, so what is this massive
But
thing they
anyway,
show here in the top of this? Oh, by the way,
let's see if we
50K
can frustrate
prize
ourselves a
money.
little
What's
more
this
by going to
massive thing that's
some
sitting
Linux.
in the South Pole? And what is this picture of it? We're going to figure this out. We got someone from Brazil. Welcome from Brazil. We got someone from Turkey. Sinan. Welcome to the chat. Hope you're doing well. Make sure you guys all chat.
And as you
will
probably
hit the
may know, I
like
actually
button
did do a little bit
for
of
everything you share this on socials. Let's get this thing
chat
trending. Let's get
AI
this competition
work today
first look
to
trending.
get some code. It's basically going to do we're going to do one or two things. Right? We're either going to count the number of rows by something, or maybe by two somethings, and we're going to total the number of case COVID-19 new COVID-19 cases by say date or
confusing. So we're trying to measure these
state
neutrinos with like no
or
electrical
country
charge to
or
them.
continent or
They're
something
just
like that. Okay, that's
yeah.
that's our
We're
main
gonna learn more
objective
about
for
that.
tonight.
Your work could help
I must
scientists
say,
better understand exploding stars, gamma ray bursts, and cataclysmic phenomena involving black holes, neutron stars, and the fundamental properties
it's
of
almost
the
time for my afternoon
neutrino
snack, evening snack also.
itself. Someone from India, what's up? What's up, Umar? So one thing I
Anyway,
realized when I was
just
doing my
this
little bit of
day
research on this, I'm gonna pull this over here. So
weight loss update.
there's
Supposedly
a
I've lost
a
18.2
video
pounds, although I
speaks
still
a
don't see any
thousand
difference. It's a bit
words,
of a
right?
concern, I think.
So we're gonna
Should be a
learn a
bit of a
little bit
concern,
about
doesn't
this ice cube by watching a video. This is a video I think I watched some of earlier today. Try to make it so you guys can hear it. So I'm gonna mute the other
it? Now we
music.
got a nice, look at this
Pause
beautiful
this.
large screen,
Just try
this
to
beautiful
bring
large
the sound
screen
up.
here.
And this might make this have a little bit more
Okay,
sense.
so let's do this. Let's do a.
This is why neutrinos are important.
Let's see if we can find.
Neutrinos are gonna. So they're like flying at the Earth at all times. Okay, so 5,000. I think this is the same thing. Although, yeah, this is a different video than I watched before because this is only a year old. But look, these are all the measuring devices that are underneath the ice in the South Pole. So this thing exists and it's taking measurements, and we're trying to figure out which direction neutrinos are facing because of this device. Can you guys hear this okay?
Not
Was
sure what
muted
all
earlier.
these
Yeah,
are.
volume was really low, so maybe only I can.
Let's do it.
Scientists question everything. But if you might have had doubts about any one of those neutrinos that we first detected,
We still have 7 gigabytes left.
Astrophysical neutrinos exist. After 2013, we were seeing a few high-energy neutrinos from the cosmos phenomenon. However, these alone would not.
Now, I3 is what's called a tiling window manager. Basically, have a screen, you have a number of terminals in it, and that's it, folks. Well, this apparently has some other things part of it, but that's the main thing about a tiling window manager. It's rather have a nice pretty picture on the screen and a nice little terminal windows and stuff. All you have is a screen with terminal windows on it. Okay.
This video doesn't seem to have all the details.
So let's go and look at this. I also went off to chat.
Okay, so we know that finding neutrinos is important. This is the one I watched earlier. No, this isn't the one I watched earlier. Where is it? Ice Cube. Neutrinos. It was about 8 years old. 2 years. This one. Neutrino. Ice Cube. Measuring the unexpected. Whoa. Alright. Let's get to work.
I don't like this problem. You would think it'd be lighter and faster, but it really isn't.
Tell me when you guys get the point. Audio is desynced. Oh, maybe because of delay. Good morning, Lanta. Alright, so this is how big this thing is. One of the things I thought was pretty interesting was
So I went up to Chat AI and I did a few awk queries on how on about writing awk scripts. So we have one that counts the total rows by a column. There's date or content of the country, it counts the total rows. So there's another one that actually
why they need to do this in the South Pole.
calculates the total something, the total in a row, rather than just counting the rows. It's going to, in particular, what it does is it's going to count the number of cases per day. Now the trouble is, uh, uh, the data, the COVID-19 data. Uh, well, the COVID-19 data has
So
some
light,
summary rows in it. I don't
so
understand
ice is
why.
just so crystal clear that the light can
Okay,
travel.
so I
much
mean, you look down there, and all of a sudden there's like a world column, and the world will be the totals for the world by day. Well, we don't want the world.
It's just like the most pure thing.
We don't want the
Hi, this is
world.
first time watching your stream. Just curious how much depth you go into understand the context, aka how is it relevant to the model? Actually not this much, but these videos are pretty cool and interesting. So I think they give us a good idea of what's going on. I'll put this link in the description too. This one is about 8 years old, so I don't know if it's out of date. But it seemed like a good video to get an idea of what was going on. Now I'm going to turn the music back on, so let's turn that volume down, and hopefully it sounds okay to you guys. This is going to be really fun. So we're trying to detect, using this sensor information, all these different sensors, the direction of the neutrinos. Let's see what the evaluation metric is. The evaluation metric isn't super straightforward. So we're trying to predict the azimuth and the zenith values, which together will go with each with an event ID. So there's a special notebook that details how the scoring metric is computed. It's the mean absolute error of the angular distance between two directions. I think I saw some examples in the notebooks that will probably explain this a lot better. Is it tabular data competition? Yeah, it looks like it's sort of tabular, more like signal data. But we shall see. Timeline, start date, prizes, code requirements. Okay, so let's look at some of this code.
We're looking for the window manager.
Definitely uploaded some of these earlier, but there's so much going on, so much
Is MySQL actually
exciting stuff
installed?
in this competition. So we kind of looked at the data here before, but I've also already downloaded the data into my mounted My Disk folder, and I have this Kaggle Ice Cube data folder. Now we can see here there's a zip file that I could probably delete. It's about 90 gigabytes. But if I do
the guy responded to a question.
is about 200 gigabytes.
If you come down here.
Yeah, so what are we predicting? We're going to get that. We're going to get to that. Before we do that, let's just look at what we have in terms of data. So if I go into,
well, that's pretty easy to understand, I guess.
So if I
you can't get much simpler than that, right?
I go into IPython. Let's list what's in this directory. Let's import pandas as PD, and let's just read this Parquet file, which is train metadata. All right. So now if we look at the data frame head, once this is loaded in, it's kind of big. So let's kind of see how big this is. Train metadata's 3.6 gigabytes. So let me see.
Just do an
sure
ICW.
My computer's not overloading with memory. No, it's just taking its sweet time to read in this large file. What do you do outside YouTube? I have a full-time job. I'm helping run a Kaggle competition for the NFL right now. Other stuff like that. All right, so the shape of this.
That crazy carrot. That crazy
131 million rows.
Okay. Or we could come in here
Let's
like
see how
so.
many unique event IDs. I think the event IDs should be unique.
Shouldn't be necessary, but
Zoom, please. How's this going, Imposter Engineer? I'm trying to keep it zoomed out enough that I can still see the memory use here at the bottom.
so let's do this.
We're just trying to get some general metrics of
Let's
what we
do
have in
a
this data
Excel
set, but
file.
it's
We start
large enough
graphics
that I
servers.
think we might want to use polars here. We're only allowed to watch if we buy 4K monitors. I hope not. I'm trying to make it screen as big as possible for you guys. Data-wise, which NFL team
Exit.
is the best? No comment.
Reboot.
I really wouldn't know. That's a good question, though, Joseph. All right, so we see that the shape of this data frame is the same as the number of unique event IDs. So this metadata has these events.
Uh-oh, this doesn't look good.
And then we also
good,
can see which batch that they all sit in. So there is this metadata, and then there's in the actual train folder all these different batches of data. Look, it goes all the way up to like 660, it looks like. So a lot of data. Each of these is 162 megabytes, and we're gonna have to figure out. Someone else in this notebook has done a great job of doing some of the basic exploratory stuff, so we may skip over a little bit of this and just learn from them. There's also the sensor geometry, which shows us there's a lot of cool 3D plots in this because of this big huge thing that sits on the ice or under the ice. We can actually visualize the sensor data that we have. So these are all
that didn't seem to work, did it?
Sensors, those little balls of light sensors,
It's completely shut down.
In 3D, so we can see how they kind of sit, and then
that's important.
This is our training data.
I'll be right back. I gotta go to the little boy from
It's basically different values for each of these sensors. These over here. And the thing is, there's this let's also go into the data set. Probably instead of me just assuming, let's read about this. So there's also this auxiliary, which is a Boolean value. So let's see what an example event looks like. The following image shows a visual representation of the features of an ice cube event in the dataset. The colorful dots represent sensors that logged at least one pulse in the event. The size of the dots corresponds to the total charge of all pulses, while the color indicates the time of the first pulse. The left panel shows only pulses with auxiliary equals false, and the right panel shows with auxiliary equals true. Small gray points indicate the positions of all cube centers. The red arrow shows the true neutrino direction of the event. So we could see that auxiliary, if true, the pulse was not fully digitized, is of lower quality and was more likely to originate from noise. So it looks like this auxiliary is going to be very helpful for filtering out the noisy data sensors, sensor data. If false, then its pulse was contributed to the trigger decision when the pulse was fully digitized. So it's pretty clear in this one that when you use the auxiliary equals false, then it's showing just sensors lighting up in the same, and then the red line is the direction, the true directions, I believe, the neutrinos. That's what we're trying to predict. So we're trying to predict that with these two values, which is the, what is this? Zenith and azimuth. Let's remember Get a visualization of the zenith and azimuth. Yeah, so this is sort of explains what we're trying to predict. So we're trying to predict the zenith and is it viewing angle azimuth? I don't know. I love plot lead charts. Would you resample the data, or would you have to analyze it on entirety? I don't think we're gonna. Well, I don't know. We're gonna have to find out. We're gonna have to find out. So here's an example, strangely, where when auxiliary equals false, you would think the line for this would go right through these dots, but in fact, it doesn't. It doesn't. It doesn't go in that direction at all. So I don't know what's going on with this example. Here's with auxiliary equals true, so this should happen.
Anyway, it is time for my snack.
So that gives us a little bit of an idea of the data. Let's go ahead and let's see what some of the scores are. So 1.274 is the best leaderboard public score. And it looks like this person, all they did was they ran a PCA, which is a principal component analysis. Hey, Zebra, thank you for subscribing. We're going to spin the wheel for you. Let's spin the wheel for the
Let's see if the RSA is working.
If you subscribe on Twitch, by the way, I'll spin this for you. And, oh, I need to type pizza 10 times. Let's go ahead here. There we go. I think I did one extra time. Okay. That's for you. Thank you so much for subscribing.
Okay.
All right. So this is the best leaderboard, public leaderboard score right now. You can see they read in the training metadata.
Yeah. This has happened before. You know, I rebooted it, and then eventually it comes back up.
And then the number of pulses.
There doesn't seem to be any damage to the partition or anything like that. Let's try it again.
In this is the event ID, which is not necessarily a unique value. It's the event ID for each time variable and each sensor ID. Sensor geometry. So they take the sensor geometry. Sure. And understanding the data, I will explore event 67.
So what I did, I thought I fixed it. I created a separate boot partition for my installs, and I installed the bootloader there.
Find the coordinates of each pulse from the sensor geometry data.
That was the problem. I needed to.
It looks like he did do some normalizing by the average.
The important thing is that the partition, the file, XDA2 isn't damaged.
I don't like the way this is written. Kind of hard to read. Why iLoc this? Why not just query on this event?
Now it's going to work.
Uh, 10 times, it used to be 100 times. No, am I crazy? I was hoping for the dad joke. Oh yeah, it used to be. Yeah, inflation did hit. I'm not typing as much as I used to before. I used to type 100 times.
Let's go a little better here.
And I realized I did nothing else done. So then they're calculating zenith target and the azimuth target. All right, so this gives us an idea of all the sensors that fired. I guess it doesn't give us the actual value of the sensors that are fired. So then we see the direction or the angle of the neutrinos. And let's see what the model, what actually PCA components does. PCA, not components. Fit in case event pulses. So we're gonna have to copy this. Let's download this code and let's play with it
We have a
locally.
start menu added here
Shall we?
someplace.
Okay, so I'm gonna actually go to my repositories folder. I'm gonna open up this ice cube neutrinos deep ice, and I'm gonna open up VS Code here. I'm also gonna go. Here we go.
No, the one thing is, it's not.
So I made this GitHub repository with an input directory which is empty. And we're gonna have to, let's go ahead and move the file that I just downloaded, which is Ice Cube. Let's go into the notebooks folder and let's move this here. And then let's try to open it up in VS Code. There we go.
Let's do a shutdown again.
Which environment do we want to be in? We want to be in a different kernel. We want to be in, let's do Kaggle 2020. Make sure this loads. Nothing named sklearn. So we're going to have to import that conda activate Kaggle 2023 pip install scikit learn, of course, because it doesn't use its import value. What? You laugh when you saw it was on line 2K. Yeah, I've typed pizza a lot. I've typed pizza many times. Okay, so these imports work. Now it's gonna, let's change this input directory to .input, and let's make a directory. Here's the thing: the data was too large to put it in this directory, so I'm gonna have to go into input and make a directory, which I'll link ln.s my mount. This is just mounting that data, Kaggle ice cube data, into ice cube. All right, so I think this will do a soft link. So when I go into here, Kaggle ice cube data goes into. Let's remove this.
No, well, that didn't work, did it? Well, you know, it did move it over.
And let's go into.
So let's come back over to edit.
We're going to do this link again. Link this directory into here. Why would this?
What if you didn't have any manager at all? I wonder. You know, I have to say it's pretty doggone easy to get used to a large module like this. You know, it really is.
Remove this.
Let's close this down again. Well, you've now commented out
do you have any
both.
Environment you have as the base of your environments you create, like basic environment that has NumPy. I just start from scratch and then I start installing
1 for 2
stuff
on loads right now on the Puppy Linux.
All right. Let's remember how to do soft links, people. Symbolic link.
ln-s.
Path the file to be linked. And I want to do a folder.
HD0. So it didn't work this time, so we're now 1 for 3.
So shouldn't this be ln-s? This directly should be right here. Kaggle ice cube data. This is what I need to do. I need to rename this.
The Windows option doesn't actually go anyplace right away. You know, as long as the main partition isn't corrupted, we're okay.
I'm going to move this Kaggle ice cube data into a new folder called ice cube neutrinos.
Okay,
And then
let's just wait.
I'm going to
Waiting a second shouldn't make any difference. Let's just wait a second here anyway.
And I'm going to link S, the mount, ln-s, mount, Ramola, my disk, ice cube neutrinos, ice here. And now if I go here, yes, it'll link to the right directory. So all that's to say that now if I go into VS Code and I run this, it should work. But of course,
So
I
it is
don't have
grub for
Pi
DOS,
Arrow
so it really
installed.
needs to be
This is like
installed
a brand new environment. So I kind of
DOS
installing
partition.
everything like you just asked. Is that classification or regression
Or Lilo,
so that we can choose
one of the two.
appropriate model or model? It is a
This doesn't
regression
look good either.
So
Nope.
because but we actually have two different targets that we're trying to predict. We're trying to predict, remember this zenith, azimuth, these like two different angles. We're trying to predict both of them. And they could be any value that's not infinite in radians. So I guess 0 to 2 pi sounds about reasonable, right? And I believe some of these notebooks that did exploratory analysis of it showed us the distribution of these features. Yeah, so look at this. The zenith angle is generally between, like in this, I
don't
guess,
think it's going to work this time either. It's moving too fast.
between around 1.5 and
okay, this may be a good sign. So I lost track. Are we like 2 for 5 or something like that now?
Anywhere between these values. Hi from Ukraine again. Finally catch you online. Thanks. Hey, Vasil, welcome back. I hope you're all safe and everything. Yeah, thanks for joining from Ukraine. That's awesome. Isn't Zenith just observer? Not quite sure.
So now it worked.
All right, so I've installed Pi Arrow.
You know, I probably should try to install Lilo, and this install Lilo so it or grub, so this installs into the partition directory.
Finally, it's reading something.
Okay, good. So
now that I've linked that directory properly,
now that we've
long enough, let's see what's wrong with this okay, with no such file or directory. Oh yeah, this is input.
So this doesn't change anything.
All right, and then they have the sensor geometry. Right?
Let's just leave it the way it is right now. Maybe we'll try it tomorrow.
This just tells us how many
time.
sensors even are there. 5,160. We can see this is sort of like the two-dimensional space. So if I rotate like this, like that, it does look like this 3D plotly plot kind of skews things. Because it's definitely wider than it is tall in here, this view. But if we run this plotly version, is it not going to show us here? Yeah, it does show us here. So we can kind of see it in 3D. Now we're going to pull in the test data. I don't know why it has this twice. That must have been a typo.
What I'm looking at, I'm trying to figure out BusyBox. Okay, that's interesting.
So for the test set, they just give us 3 example values, events. But in reality, on the real test set, it's a lot more. So you need to make sure that your code can
Now,
run on the
what we can
larger
do is
test
we can
set
take a look at the log and see if
when
we
it's
actually get a
submitted.
hint in the log
This
what's
test
going
set's
on.
just for kind of testing out to make sure your code runs on a little bit of code. How do you feel about Plotly Dash versus other visualization when making dashboards? Well, I've been learning a lot about Dash, so I really do like it. All right, so what is this person doing here? Train batch 1, iLoc, train meta. So it's looking up in the training data. So for this case event, which is 3.
Okay. We said I3.
Why is case event 3? Okay, so case event 3 is actually 67. If I'm reading this right. Oh yeah, it says it really big here.
Oh, wait.
It's number 67. So we can see that. I would just do this. I'm pretty sure case events pulses shape here. If we just did train batch 1 query event
That may
ID
not have been the
equals
best thing to
67
do.
dot shape 142 by 4. I'm pretty sure all this code right here.
That didn't work quite as planned, did it?
You guys read this? See how much difference in code size this is? How can I change the font style in the markdown section? So font style, there's not much you can do, but you can add like a hash. This is a title. This is a subtitle.
Let's see if we'll boot this time.
Code snippet. This is normal text. You can do bullet point. And then you can do like a whole bunch of.
Okay, this looks good.
Like that. So then when you render this, it'll actually show this as code. Right? So it renders it different. Relian, thank you so much for our Ray. Leon. Yeah, thanks for hanging out. Thanks for the positive vibes. Okay, so what were we saying? We're saying the main thing.
What
here
happened if we took it down to a?
Unless there's something with the metadata, if there's some reason why we should use this first and last place. I don't think so, though. That's just the location in the batch. I don't see any reason why we should do it that way. Right, so let's just switch this out. All right, so then we take this case event pulses, which looks like this. This is something that I'm not sure about yet. Why are there different values for time?
Okay, good. Let's see here. Listen,
auxiliary
chat,
equals true.
email.
The charge value, the time value. What does this time value mean? Is this like time series? Are they not all coming in? Are all the values not coming in at once?
So how do I add it to Task Manager?
We're going to find out in the data section. Time. The time of the pulse in nanoseconds in the current event time window. The absolute time of a pulse has no relevance. and only the relative time with respect to other pulses within an event
Now, technically,
relevance.
I3 isn't
So it is sort of time series
isn't
data.
a desktop. Well, it's a desktop, but it's not really a window manager.
Let's set our index to be time,
Hmm.
and let's plot this, right? All right, so this is in nanoseconds, but these are when all the pulses come in. So this is something interesting because,
Okay, it isn't.
at least from what I've read, it
Okay,
doesn't look like people are visualizing these as time series. They're mainly just visualizing these as data points that are all for the same event, but in reality, they come in kind of a sequence. Zebra, why are you doing that with your head? Raid? We got a raid? Where's the raid? How many people raided? Someone raided me with 7 billion? How did I miss this? Let me go back. Overgrown carrot. 1. Thank you so much for raiding with a party of 7. Hope you're doing well tonight. We are just looking at a Kaggle competition here. What were you working on?
so where's the menu? Fix menu.
W is exaggerating a little bit on the number. All right, so let's also look at, we have like a time component, we have a location of the sensor component, and then we also have this auxiliary value, and then we have the charge value. Let's group by auxiliary. We'll set the index first, and then we'll also add a legend. So this tells us the ones that have auxiliary true or false. I believe if auxiliary is true, then there might just be noise. Hacking Active Directory.
Hmm.
I don't know if did Overgrown Carrot say anything. I think he just. Oh wait, no, he's there. We're doing Cyber Labs, Hacking Active Directory. That's awesome. Overgrown Carrot sounds like fun. Sounds like a lot of fun. So if you're just joining and you want to know the competition that we're looking at, here it is. Here's the link. Kaggle. You can check that out. Exodus says, I don't know anything about coding. What is that program he's typing in interface that start mode? This is VS Code with a Jupyter extension, and I'm writing Python code. So this runs Python code in a way that like us scientists can write code and then also write text next to it, but have it all kind of in the same call it notebooks. All right, so this mean normalizing that he's doing, it makes sense to reset this index and then subtracting the average value. So let's just look at this. What's this case event pulses? Why does case event pulses? here have an x, y, and a z value, but it didn't up here. Right? Case events pulses doesn't here. And we plotted this.
So,
Title event 67 by.
I can't figure out
Look at this
exactly
Copilot
where.
trying to find time and auxiliary. It was actually right. Sensor geometry locates the. Okay, so this is the same thing as a merge. This could be a merge, right? Basically, what he's doing is he's taking event case, and it could be faster the way that it's written.
So,
We have this case event pulses,
well, the
and then we
problem
also
is
have the sensor
the internet connection is really way too slow for what I'm doing here.
geometry. We want to take each sensor ID and get the X, Y, and Z location.
But I'm still logged in. That's
Let's
good.
merge sensor geometry on sensor ID, set index time, group by auxiliary. No, we just want to merge. And then how should be left. And let's see if this. Let's just make this copied. And then run the way that he
See,
did
this
it, which
just
was
runs like
doing these
really slow.
index lookups. Let's see this shape, and then both this. No, Kate, mine has one less value in the head or in the columns. Let's see where I'm missing it. Oh, that's because he also reset the index. Right. So if I do, really, you can drop those indexes.
This connection really is slow.
And then how do we do the mean averaging? Hey, Knots, Tristan, welcome. Copilot on Jupiter. Yeah, it's VS Code and Jupyter Lab. Let's spin the wheel. Let's take a little break and spin the wheel, and let's check up on chat. What do you guys think about what we're doing so far? Oh, my gift discard subs aren't working. And prop sub isn't. I had. Oh wait, drink water. This isn't water, but let's pretend like it is. Scream, Kevin. I will eventually. I'm sure I will eventually. I'm sure the Kevin is coming. The Scream Kevin is coming. You guys just need to subscribe on Twitch. So this is one way to do it. Just like divide by the mean value. You can also from sklearn pre-processing.
We could do something funky like this. Okay.
Min-max scale. Like we could use like a legit scaler.
Okay. We could do something like this.
Like standard scaler. KNN it seems. Excel learning by Excel expert. What's up in the chat? Yeah, so let's look at this. Let's look at this. I kind of want to look at this before normalizing. Oh, that's just averaging by the average X, Y, and Z values. that's a good idea. Let's plot a kind equals histogram. This is breaking me because I'm running it out of order. Case events pulses. Now if we do a histogram of this, like the x value we can see is between negative 500 and 600. And if we do the histogram of, try all three.
No, we could do it.
X, Y, and Z.
I'd probably
And
quicker
let's make
to.
more bins and make it alpha so we can kind of see through it. Right? So the X, Y, and Z values kind of vary between negative 100 and this. So it's taking the mean value of all these. If we do the mean value, and that's just for this one case. But if we look at a lot of them, I bet it's going to average out to be a pretty smooth, normal distribution. I'm just guessing. I don't know for sure. All right, so the average value is actually negative.
It'd probably be
for most of these,
quicker to
and
go over here.
That's what we're subtracting out here
And
in that line of code that they did. And this subtracting out the mean value. I don't know if that's the best way to do it, but let's
try this.
Let's actually
Let's
do
just
one of
try
those histograms
cloning that repository.
Train
Okay.
batch 1. Which has.
You know what? This is almost a little bit too small.
Sensor ID. Oh, that's the index. That's an index. Hey, what is this little gift thing? He gifted Z-bars. Thank you for gifting subs. Let's go ahead and see if we can get Kevin. We can scream Kevin as loud as we can. Will it land on scream Kevin? There's a 10 chance out of all these summed. Do nothing. I'm sorry. I'm sorry. I appreciate you gifting a sub. That's very nice of you.
That's pretty good.
You gifted it to Data Basics too. A good friend of the channel. So we have a lot more values if we look at this whole batch.
Okay.
So we're gonna try this same plot with batch 1.
That's a little better, I guess.
Batch.
So we're gonna say.
That's right. We need to, if we want to do that, we have to merge this entire data frame with the sensor geometry on the sensor. I love how it's doing all this stuff all together. So we're gonna try this merge left. Now it has the X, Y, and Z. So we'll copy this. And then we don't actually have to merge it again. This is something we should probably do in polars if we actually want to make it fast. Hi there, Omak, what's up? Welcome. You can always watch the replay. Okay, so this is interesting to see. Like, if we normalize by the average value of all of these, it's gonna maybe be better. I don't know, maybe worse, but it's gonna really change. The average value is gonna change depending on which event we use. The average X, Y, and Z value.
So in the end, it's easier to to do this with.
I'm doing well, Rauk. How's it going?
To do this with
All right, so let's not go too crazy with this, and let's see what they're doing. They're taking out the zenith and azimuth.
We got notes in chat DI. Let's try.
And then then making an array from negative 100 to 500 with this shape. Okay, that makes sense. And just drawing it here on the plot of all of the sensors that have fired. I wonder if a lot of these targets that fired are actually these early ones. Do you see that? Do you see how so blue is, I believe the color is blue if it's auxiliary, and if it's not auxiliary, it's blue. Otherwise, it is red. And in this, it's actually the opposite. It's orange if it's auxiliary, and it's blue if it's not. But look how we have these few values here at the beginning with the time that's less than, let's say, 15,000. And then we have ones that are greater than 15,000. I wonder if that's why we have some blue things over here that aren't by the main line. Let's see if this has something to do with the time period. We're already filtering out here. These are like old school ways to filter. Like we could just do query. Auxiliary. And that'll do the same thing as this whole line of code. Right? Queries are friend. And then we can do here not auxiliary. And it should make the same plot. But let's also query time. Make sure we have the right value here. Yeah, it's just called time. Time is greater than 15,000. We're filtering down just to the right side of this plot for this event. See if it's anything different. If it's different, if we just split here, you can actually do 17,500. That might be a little bit better. It's just kind of a side tracking, little bit of a maybe a red herring here. No, but look at this. It kind of matches what, right? It kind of takes out some of the data that is not lining up with the line. So that's kind of interesting to think about. This might be a pattern where you want to like cluster by the time dimension and only consider when they're grouped closely together. Do they say anything about the possibility of two neutrinos at the same time? I don't know. We haven't read any papers yet. That could be what's happening. Like this is an old one and this is the new one, but they're both considered event 67. So I don't know. Maybe it's going to be an iterative thing where we need to take out values that are not associated with it. All right, so
no, this is just going into. No, it should create a repository called.
He's making a principal component analysis with only one
Okay.
component.
Close that.
Fitting it on
Open.
all these XYZs. I don't understand how this works at all. So there are three components here. Okay, one for each X, Y, and Z. And how does he take this X, Y, and Z?
Well, we got here. I went out to chat to the chat AI. I did it actually on the Windows side. Then I created this repository for some notes and code I was looking out there. All right. Oh, that's not good.
Negative 227 to positive 227. I don't know. It works. Seems to work. And then he's scoring, and this is the angular distance function that we're given as the actual function for the scoring of this.
Okay. I'll be right. Give me something to
I'm
drink here.
starting to understand. I think I'm starting to sort of understand how he's doing this. So get angles of the event data frame. If auxiliary is greater than 15, so that's one interesting thing we should look at is how many auxiliary events. Like if we group by an event ID, for some reason we dropped the index in the train batch 1, which has the event ID. So there's a lot to do with that. Hello, this is off topic, so answer whenever, but new year and new to code, started to learn, I would say strong beginner, having trouble understanding structure of programming in general and how different entities communicate. Any suggestions for how to get started with that? Just take a basic intro to
Okay, so now we got a few notes here.
or watch a lot of YouTube videos. Hey,
So
that's another way to learn. You just gotta
let's give
stop
ourselves as
asking.
much room as we possibly
I
can.
don't mean to be mean when I say this, but I've been in this situation too, where I just ask a lot of questions. But instead of asking the questions, just go out there and try to watch a course on it, like on the very specific topics that are holding you back. Yeah, Free Code Camp is great. I did edX course on Intro to Programming when I first started. It was really helpful. So
Let's see.
I'm starting to think maybe he did it this way is because it's faster, like doing the iLope stuff instead of
Okay.
query.
So
When you're running this on the test set,
let's
it needs to be
try.
pretty fast.
Let's see something.
All right, so let's get into. Let's get into the actual. If we were to build a deep learning model on this, what would we do? And I'm fairly certain that I saw. These are people trying to figure out how many values or events are in the test set.
So let's just go over here. Let's see what it's supposed to be doing. It's only supposed to be counting the first column. Well, first of all, let's come back over here to make sure.
Not all sensors used in one batch. Notebook theory essential.
Okay.
Do we try to predict an algorithm? What I'm trying to find here is someone linked
That's interesting. Okay.
to a paper. Let's go to Google Scholar and let's look up deep
Number
learning
one.
for this. I know I read this paper earlier today. Neutrinos and deep ice.
Okay, I think by default,
This is not the one I
I
found.
think it's looking for spaces.
But it does kind of give us an idea of what type of model we might want to start with. The one I was reading before actually used the time dimension also somehow.
Mm,
Why you should.
there should be a.
Oh, this is it. Deep learning reconstruction in Antares. Antares is currently the largest undersea neutrino telescope. So this is an undersea one. It's not. It's in the Mediterranean Sea. It's
Field
different than this
separator.
one because it's not in
Okay, good.
ice. It consists of a 3D array of
So let's just try
photosensors
this.
instrumenting about 10 mt of seawater to detect Cherenkov light induced by secondary particles. It sounds like a fairly similar thing, right? And when I was reading about this,
Okay, good.
this was their
Good, good, good.
inputs. This was their structure.
Okay.
So even though their
So,
model says it that way, they say in their data processing section that they use a
so there's dates,
four-dimensional
there's years.
input of images containing the full spatial and temporal hit information. Therefore, the spatial bending chosen such that every floor is one pixel in the image, leading to a pixel grid of. So this is they call it an image, but it's kind of like just a tensor, a three-dimensional tensor, 4 by 4 by 25. And then they use these time bins. So this is where that time dimension might come into it. If we're actually
Right. So we're actually going to
trying
change.
to. This is highlighted. Where is it? We're trying to sort of separate out this time dimension. We could feed it to the model in this way, but I'm not completely sure if this will
Yeah,
work.
sometimes it's fun
And
to
if
like
we
go
see
through and hit
how
the
their
tab key and just see
model
what you got out
structure
there.
looks,
Okay.
I'm not quite sure why it's 25 by 161 by 3 because they just said here the dimensions were different than that. 4 by 4 by 25 by 100.
Okay.
So let's just ignore that for now.
Let's just come back up here.
So this is just like a simple model structure that we could recreate. We could with PyTorch make this exact same model structure with all these exact same sizes. We could test it out. It's a completely different um, um, data set that they worked on, but we could try this application on this new data set and see if it works. This is their model, this DCN, and you can see how it's much cleaner in the way it was able to predict. So I don't know. Looks like it has some potential here. But let's actually see this. Let's see this. One thing I'm curious about.
What do we change? Change this to 4.
One thing I'm curious about is, is there only one sensor value per event? Make sure I am in latest Kaggle environment that I created.
Okay, up here I didn't set the.
And let us look at batch 1. Let's group by the event. Let's group by the index. Let's reset the index. Then let's group by, I don't know if there's a better way to do that. Event ID. Can I group by just the event?
I don't understand what that
and
is.
then let's do event. Let's do sensor ID and then n unique, the number of unique
Because we're
times.
trying up to here.
We might actually want to do like a value counts on that. So what we're trying to find out is for. All right, so this is telling us. This is telling us for each event how many unique sensors are there. For each event, how many unique sensor measurements? So most of them are pretty low, and if there are 4,000, forget how many. So if we do the same thing and we do a value counts. Hi, Thomas. What's up? AVRG50. What's AVGR50? Okay, so this is telling us that each sensor ID actually could be multiple times, could occur multiple times. I did not expect that.
So that gives us the count.
Let's just see. And granted, we're only looking at a single batch here. Just in general, which sensor ID is the most common? 5038. Let's do this plot where that other people were doing where they're showing sensor data. I'm going to go in here, sensor geometry. Input the sensor geometry. Oh, it's a CSV. And then let's also import plotly express as px. So let us do our 3D plots. Also load an extension. Lab black. Put this all the way up here at the top. Come on, plot, don't fail me now. Let's take the top 50. Yeah, so this is the top 50 sensors in our batch 1. So only the top 50 sensors in batch 1. And let's see if they're in a specific location. So if the sensor ID is in this, that'll be our second plot. Okay, so made two plots actually. Let's just show this one. All right. So this is kind of interesting. I don't know. It's like the outermost.
You know, it's probably just the name of it.
Okay, so we can color this by sensor ID, and we basically want to do the sensor geometry and merge this on our value counts, right? We can map this, actually map the sensor ID, and this will give us the batch 1 value counts for each sensor ID into the sensor geometry data frame. Batch 1 count. So that's like a new column in our sensor geometry. Why does it keep on? It's not defined. It's definitely defined. Hi, Lance. Hi, Lance. What are you talking about? So we're going to color by this on the count. Value color is not the name column in the data frame expected one of sensor ID. Oh, because I reread this in. That's why. That's why it's complaining. Highlands was correct. I was wrong, okay? I was wrong. I can admit when I am wrong. Alright, so looks like these bad boys here in the middle. Interesting shape for sure. These ones in the middle, and this is like the slowest way to zoom ever, tend to light up more commonly, and just in general, the lower ones tend to fire. Why is that? I don't know. I don't know. I did see someone posting that they saw examples where like all of the just one rod was firing, and someone said that was probably because of bad measurement or something. Yeah, this one. So Darian posts about this. Look, this auxiliary equals false. All the values are within this one rod, I guess I'm calling it. I don't know if that's the correct term, but it looks a little odd. And Robert Hatch responded and said, neither pure noise nor you're overthinking it. It's mainly an artifact of cost-effective placement of the sensors. For increasing X and Y density, you have to drill another hole in the ice. So very expensive. So increasing X and Y density, that means like it's the space. For Z density, they just need to add a sensor to an already existing giant string of sensors. So small Z movement is much easier for the sensors to detect than small X or small Y movement. Since it's 125 meters XY distance versus 17 meters of Z distance, triggering 3 to 4 vertically stacked, and that's far less distance apart than neighboring XY string. So I think what he's saying is, yeah, this Z axis isn't as deep as it appears.
So if we say
they're
two,
not actually this deep.
this should give us the country names.
And they're actually tightly packed in there. I don't know. Hello, Pro. What's up, Nguyen? Good morning, sir. What's up, Idris? Idris. They trigger. Yeah, so the height is tight, and if it triggers one, it triggers them all.
That's
If
interesting.
we go one, we go all. So we're trying to understand this. Now here's the next step that I would probably take on this. If we want to make a PyTorch
Okay,
data set,
good. After we want the
set,
output separator to be
an input and target for each event, what's the size of the tensor that's coming in? And maybe just to start out, we don't care about this time dimension. What I was hoping is that each sensor ID would be unique.
What am I thinking of?
Be unique. And it doesn't appear that way. Well, let's just try to think. If we were going to make this, into a tensor for each event, and then we also want the target value, which is train metadata. Nope, we want this in train metadata parquet. This is fun. You guys having fun? I'm having fun. Hope we're all having fun. So we want to take this each event, and this is our target. This first pulse index and last pulse index, I don't think really matters. What if we did this auxiliary equals false, group by one thing I noticed was in the other person's notebook, they had a different way that they fit their model if there wasn't a lot of auxiliary equals false values.
Let's try that.
So I guess we can group by the. Can you group by the index like this? Let's reset the index. Let's group by the event ID, and then let's do auxiliary. And then do a value count of each. You can unstack this. What are people saying? Why do I use query over loc? Because I think it's easier to read. But I think it's a little slower. What is lab black? That is an auto. That just if you go to NB black, there might be a better way to do it in VS Code. But it's an extension that automatically will run the black formatter on all your code when you run a cell in Jupyter, which keeps it a lot easier to read. So I'll send you guys this link. All right. This is just our auxiliary stats. I just want to see how it did that auto formatting. So much cleaner. So for the auxiliary stats, if we want to go by faults, we could just do the whole thing. Plot kind distance what? There's one where it's over 10,000. It's over 10,000?
So we could say begin.
What is going on with this event? This event has so many values. Train batch 1. Oh, actually, if we go to train metadata, and then we query, is why I think it queries cleaner, event ID equals this event ID. Like how Colab tried to, I mean not Colab, Copilot tried to say event ID equals a bunch of zeros. All right, so first pulse index and last pulse index, that's a big distance. Like we could subtract these to get the pulse index, and this will be our train pulse length. We're just exploring here. Trying to see how common it is to have pulses that are that long. It seems exceptionally long. We could actually make one of these plots for that to see if it looks any different. It might just have a whole mamma jamma of noise.
Oh, perfect. Absolutely perfect. So,
My memory use is out of control. Let's
but
restart
instead,
this one. Restart this one. Still getting kind of out of control.
let's
We
just
need
do
to
a,
use polars here. Pulse length. So it's kind of hard to see. Kind of hard to see by just sorting. We need to plot a histogram. And I guess we need like a
I
lot of
thought we were
bits
just
to
counting
show
rows.
this.
That'll be
Maybe
right.
100K bits. This is important to know because our training data has like mostly short events, but then a couple of really long events.
Let's take a look here. File. Let's do something a little crazy here now, shall we? Let's come back over here. Let's do a sort. So at last, we've accomplished a little something here tonight, right? There we go. No big surprise there, right? Now, and come over here now. So that was, which one was that? That was continent. All right. Now, if we come down here, See, to me, I don't understand why they put this in there for. I mean, you shouldn't be putting summary columns in these rows. Where is that coming? Okay, so okay, why is that not reading that as a date? First of all, let's come over here. This. Hmm. Why are these rows? Hmm. The output separator is working just fine. How come these are all going on the wrong line? And this is correct here then. That's not really what we're looking for here then. Hmm. Hmm. this isn't correct. Hmm. That certainly is interesting. Now, like I'm not really that big. Let's try some here. Hmm. Hmm. No one's going to come and see me this evening, I guess. Hmm. 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 we did get some numbers, although I'm never really sure. Now there's a question. Hmm. Hmm. Well, I tell you what, friends, I'm gonna go ahead and call it an evening. Uh, been an interesting and a semi-productive evening. We still haven't finished a session on WorldQuant University for that 28th, was it 24? Uh, well, it says here that concurrent viewers 3. Well, if you folks are there, I'd appreciate if you would actually stop in and say hi. Average duration is quite good, 14 minutes. Good, good, good. But anyway, thanks so much for everybody who stopped by. Hope you learned a little bit. If nothing else, you had a little more frustration there is when working with data. I'm not sure. I think let's say I'm definitely satisfied with the monitor, as you would expect. There, how's that? But nonetheless, I'm going to call this evening to a close. I'll be back at it again tomorrow night, Wednesday evening, 8 p.m. sharp. Maybe not too sharp, but sharp nonetheless. So again, thanks so much for stopping by, folks, and we'll catch you tomorrow evening at 8 p.m.